In this video, we're going to be talking about adding and subtracting rational expressions. So before we do that, let's talk about multiples of whole numbers, because we're going to have to think about multiples of factors of fractions in order to add rational expressions with like and unlike denominators, and also subtraction as well. So if we wanted to find the least common multiple of 6 and 15, one thing we could do is just to list the multiples of each of the numbers and then just find the first one or the smallest one in each of the lists. So here we have the multiples of 6. Remember, you can find multiples by multiplying a number by the whole number, 6 times 1, then times 2, 3, 4, etc. So multiples of 6 are listed here, and the multiples of 15 are listed, and the first one they have in common is 30, or the smallest one they have in common is 30. So that would be the least common multiple. There are other common multiples of 6 and 15, 60 for example, 90 would be another one, but 30 is the smallest common multiple. So we use this when we're adding or subtracting fractions with unlike denominators. So when we want to find the least common denominator, or LCD, we want to factor all of the denominators completely if the denominator is a polynomial with 2 or more terms. The least common multiple, or least common denominator, will contain all of the different factors for all of the polynomial. If a factor is already in common, then we use the highest exponent. So here's just 3 examples of finding the least common denominator. All right, so in this case, we have monomial denominators. So we're looking for the least common multiple of 8 and 12, which is 24. And then since we have a's in both denominator, we'll take the one with the higher exponent, which is a to the third. And since we have b's in both denominators, we'll take the one with the higher exponent, b squared. So the LCD is 24, a to the third, b squared. For the second example, we have trinomials in the denominators. We would have to factor these trinomials completely and then take all of the different factors. So you should pause this video, take a moment, factor those trinomials, take all of the different factors that you see, and you will see that if we listed all of the different factors, we would have m minus 3, m plus 6, and m minus 4. So we would just write that as a product. In the third example, again, factor the denominators completely, and then make a list of all of the factors that you see. So we would have common, not necessarily common, we want to take all of them even if they're not in common, but all of the different factors of the denominators here would be x squared, x minus 3, and x plus 3. So we need to use the least common multiple or least common denominator to add fractions or subtract fractions if the denominators are not the same. So here's just a place for us to revisit what happens with regular fractions. If we were adding the fractions 7/12 and 5/18, the denominators are not alike. So we would need to find the least common multiple of 12 and 18 and then change the fractions to have that common multiple in the denominator. So the least common multiple of 12 and 18 is 36. And this is just one way that you can also find the least common multiple, which is different than what we had done before, where we listed out the multiples. This uses the prime factorization for 12 and the prime factorization for 18. So for 12, we have 2 times 2 times 3, and for 18, we'd have 2 times 3 times 3. We need to take all of the common factors, which would be a 2, it would be a 3, and we take the higher exponent. So in exponential form, this 12 would be 2 to the second times 3. So 2 to the second compared to 2 to the first, we take 2 to the second. And for the 3's, we have 3 to the first and 3 squared, we take 3 squared. So the LCD there would be 36. Now that means that the fractions would need to change. So this 12 needs to be changed into a 36 by multiplying by 3. Therefore, we multiply the numerator by the same thing. The 18 needs to be changed into a 36 by multiplying by 2. So the numerator has to also be multiplied by 2. We're always multiplying the same thing in top and bottom of each fraction. After we multiply, we have 21 over 36 plus 10 over 36. These fractions are equivalent to the original fractions. They are just not simplified. But now we can add them together, and we would get 31 out of 36 as the sum. All right, so we're going to use this in 3 examples, 2 addition examples and 1 subtraction example. The answers here are in blue, but I'm going to show you in detail how to get those sums and differences. All right, so let's start with the first example where we have 2 over 9x plus 5 over 3x squared. The denominators are different, so we need the least common multiple of 9x and 3x squared. These are monomials, so we don't have to factor. We can think about the least common multiple of 9 and 3, which is 9, and the least common multiple of x and x squared, which is x squared. That means our least common denominator is going to be 9x squared. Then we're going to use that denominator to rewrite each of the fractions. So for the first fraction, I need to multiply the denominator by an x to make it 9x squared. So I'll multiply the numerator also by x. For the second fraction, I need to multiply the denominator by a 3 to make it 9x squared. So I multiply the numerator by 3. So I'll go ahead and do the multiplication. So I have 2x over 9x squared plus 15 over 9x squared. And once I have the same denominator, I can just add the numerators. The numerators are not like terms, so I'll just rewrite it as the sum 2x plus 15 over 9x squared. Let's take a look at the second example. Here the denominators are binomials, but they're not factorable. So the LCD is going to contain each of those binomial factors, x minus 3 times x plus 1. So I'm rewriting each fraction with this product as the denominator. So the first fraction, the numerator is multiplied by x plus 1, so that the denominator is also multiplied by that, and I have that LCD. In the second fraction, I need to multiply top and bottom by x minus 3. Notice that the denominators are the same, even though the order of the factors are different, the product is the same. Now in order to add these, we need to multiply the numerators. I'm going to multiply those binomials together. If you need to pause this to check the multiplication. I also multiply the denominator here. You really don't have to multiply the denominators. I just happen to here. That's a minus sign. X squared minus x minus 6. And again, I'm multiplying the denominators, but you certainly don't have to always multiply the denominators. The numerators, however, you do. Because now the numerators we're going to combine. In this case, we're adding them together by combining like terms, which gives me 2x squared plus 2x minus 4. And my denominator, well, I can factor that numerator. So I will go back to factored form for my denominator here, because I can factor the numerator. And if I can factor it, maybe I'll have some common factors. So I'm taking out the GCF of 2. And then I'll see if I can factor that trinomial. Looking for two numbers that multiply to negative 2 but add to positive 1. So that trinomial can be factored into 2 times x plus 2 times x minus 1. So in this case, I don't have any common factors. All of the factors are different, but of course it is always worth your time to check to see if you do have a common factor. Right, here's our last example. So what we're doing here is we need to factor. So we're going to factor the trinomial and that factors into z minus 4 times z plus 3. And now my LCD I will build by taking all of the different factors. So I see a z plus 3, I need to have it. And then I also see a z plus 4, minus 4, I need to have that. I already have a z plus 3. The exponent on each of these is 1. So that means I need to take my first fraction and multiply the top and the bottom by z minus 4 so that it looks like my LCD. So whatever factor that you need to make the bottom look like the LCD, you just multiply that on the top too. Now the second fraction I don't need to change because the denominator is exactly the same as the LCD, so the numerator doesn't change. I put the parentheses around that numerator to remind myself when I subtract that I want to subtract all of the terms of that numerator. Before I subtract though, I do need to multiply the two binomials together. I'm going to distribute that negative, minus z minus 17. I could automatically put this in one fraction. The denominator is z plus 3 times z minus 4. Then I'll just go ahead and simplify the numerator by combining any like terms. And if I can factor that numerator, I will factor it as well. So I'm leaving my denominator in factored form. Right, so I can factor the numerator into z minus 7 times z plus 3. And now I do say I have a common factor of z plus 3 in the denominator. So I can cancel out the z plus 3, and that leaves me with z minus 7 over z minus 4. All right, thank you for watching this video. Hope you learned something.